Welcome back, folks. In this class, we'll talk about some math problems on the momentum. So, in the very first question, you are provided with the object has a constant momentum, which is equal to 2.45 times 10 raised to the power 2 kg meters per second in the north direction. Determine the momentum of the object if the mass is decreased to one third of the original value. So mass nu is equal to one third of the previous mass. I'll call it as old mass. And the speed and the applied force causes the speed to increase by 4 times. So new speed or velocity in this case, I mean the direction is not given, but I'll keep the symbol as v. So it is equal to 3 times or 4 times of the previous one, 4 times v old. All right, and the direction of the velocity remains the same. So if it is north, so this will be the north, and explain your reasoning. So basically they are asking us to solve these questions. Now I'm going to solve it on this side. So the initial momentum given to me is equal to 2.45 times 10 raised to the power 2 kg meters per second. And the momentum formula is also equal to mv. Now, if I look into this formula, it says that momentum is directly proportional to the mass and also directly proportional to the velocity. So on a side note, I'll write it as P is directly proportional to m, P is directly proportional to velocity. What does that mean? It means if I increase the mass, then momentum will increase. If I increase the velocity, then momentum will also increase, and vice versa. So if I decrease the mass, then the momentum will decrease, and if I decrease the velocity, then the momentum again will decrease. So I'll use the numbers. So the momentum is 2.45 times 10 raised to the power 2, and it says the new mass is one third of the old mass. So I'll multiply it by, just directly multiply it with whatever the number given to us is, one third, and the velocity is, new velocity is 4 times the old velocity. So multiply it by 4. Then that will give you the new momentum. So this is equal to, if I solve this calculation, and this should come out to be 2.45 multiplied by 4 divided by 3, that comes out to be 3.2667 times 10 raised to the power 2. This is the final answer. Again, units kg meter per second or Newton second, whatever units you wanted to use, you can. That's how you're going to approach this question. Now let's look into another question. So during the part of a liftoff of a model rocket, the momentum increases by a factor of 4, and while the mass is halved. So momentum is, new momentum is equal to 4 times old momentum. And the velocity of the rocket initially is, velocity is given to me 8.5 meters per second. Mass is halved. I missed that part. I need to write down that too. Mass new is equal to 1/2 of mass old. Now in this case the velocity is given to me, so, and I've been asked to find out what is the final velocity during the time interval. Now because I've been asked to find out the velocity, so I'll write formula in terms of velocity. So momentum formula is mass times velocity. The velocity formula in terms of momentum will be equal to momentum divided by mass. Now, what does this tells me? It tells me that velocity is directly proportional to momentum because momentum is on top, and velocity is inversely proportional to mass. So if the mass goes down, velocity will go up. If the momentum goes up, then the velocity will go up too. Now, I just need to plug in the values. So I will write down 8.5. Momentum is on top. It's on top, like directly proportional. So multiply it by 4. And mass is on the bottom. So I can look at from here, from this formula down here too. and this is 1/2. I'll replace the m with. And if I do this calculation, you will find new velocity is equal to v new is 68 meters per second. Now, easy way to do this calculation is you can convert 1/2 into 0.52, and then if you are struggling with the calculations, your calculation will become super easy by doing so. Now, let's look into another question on the momentum. To improve the safety of the motorists, the modern cars are built so that the front end crumbles upon impact. A 1200 kg of a car is traveling at a constant velocity of 8 meters per second. There's a 1200 kg, oops, a 1200 kg car is given to me, which is traveling at 8 meters per second in the east direction. It hits the immovable wall and comes to stop. It's gonna hit this car and gonna come to stop. Means final velocity is v final is 0 and v initial is given to me, which is 8 meters per second. Calculate the impulse provided to the car. I wanted to find the impulse. So if you can recall the previous lectures which we talked about, impulse is equal to what? Impulse is change in momentum. So impulse equal to delta p, which is equal to p final minus p initial. Now, which formula I'm going to use? It has a lot of formulas. So delta p can be called as area under the curve, area under the graph. It can be equal to p final minus p initial. Okay, now which formula I'm going to use? Area under the graph, if I get into the detail, two formulas we talked about in our previous lecture was f net average times delta t and 1/2 times force peak times delta t. I'm a little confused how I'm going to approach this question. So I'm going to look into what's given to me, and based on that I'll try to use the formula which will fit to the best of my needs. I've been given with the velocities, right? And then velocity, in terms of velocity, I can recall the formula delta p is equal to m v final minus v initial. I've not been provided with any force. Okay, although I've been provided with the time, but no force is being provided to me. So I cannot use this formula. I cannot use this formula. The only formula left is p final minus p initial, which can elaborate it into m v final minus v initial. Thus, I'll use this formula. Now, if I plug in the values and go back to the question first of all, so this comes to the rest, means v final is 0. So v final is 0 minus initial value is I guess it was 8 meters per second. So 8 meters per second. Mass was 1200 kgs. And if I do the question, change in momentum comes out to be, that is 9.6 times 10 raised to the power 3 Newton second or kg meters per second. Okay, and then this is a negative number. Negative number means change in momentum will be 9.6 times 10 raised to the power 3 Newton second in the west direction. That is the change in momentum. Now we've solved for the part A. Calculate the impulse provided, which is equal to change in momentum, as I said, and then what is the average net force on the car. Average net force we wanted to find out. So F average multiply by time, which is equal to impulse or change in momentum. This is the formula I'm going to use because they are asking us to find out the average force. That's why I end up using this formula. So force average multiply by the time, and the time duration given to me in this question is it car comes to the stop within 0.25 seconds. So I will multiply it with 0.25, and down here this is delta p given to me, which is equal to change in momentum, which we've already calculated, which is 9.6 times 10 raised to the power 3. I'll use the negative sign because this is in the west direction. This is negative. and dividing both sides by 0.25 now, 0.25. And once I'm going to divide by 0.25 seconds, the number will come out to be force average will be 3.8 times 10 raised to the power 4 newtons, which is a negative number. Now, because it's a negative number, so I'll write it as net force average is equal to 3.8 times 10 raised to power 4 Newton in west direction, which is force average. Okay. Now let's look into the part number 3 for this question. It says, what would be the average net force of the car if it had a rigid bumper and the frame that stopped the car in 0.04 seconds? So I'll encourage you guys to pause the video and try to solve it on your end first of all, and then I'll do it. So again, welcome back. It's F net average, what we are looking for if the car stops in time 0.04 seconds. So same thing, change in momentum is given to me, which is equal to 9.6 times 10 raised to the power 4 newtons. I'll write down the formula here. This is equal to delta P equal to force net average. Net average or average means one and the same thing. Again, guys, don't confuse yourself. This is equal to net average, which we are looking for, multiply by time, which is 0.04 seconds. Now dividing both sides by 0.04, and if I divide this number with the 0.04, this is negative number because the change in momentum is in the west direction. That will come out to be 2.4 times 10 raised to the power 5 newtons. Again, this is negative force net average, and then I can finish the question by describing by writing down the direction, time 10 raised to the power 5 west, and this is newtons. This is the unit equal to F net average. All right, so hopefully you were able to understand how to approach the questions. So the idea of solving these 3 questions is so that you can find out which formula to use when and how you can modify a formula to find out a number. So if you are given the velocities, I'll recall a little bit. If you're given velocity initial and velocity final, then you will use the formula as P equal to mv final minus v initial. This is the formula you will use to find the change in momentum. If you are given force and time, these 2 things are given to you, force and time, then you will use the formula impulse or change in momentum is equal to, again, depending upon the question, force average times delta t, or 1/2 times force peak times delta t. Again, this will depend upon what kind of a graph you are given. If you are given this kind of a graph, then area under the triangle. If you are given this kind of a graph, then you will use the first one. Okay, so hopefully you were able to understand how you can approach these questions. I'll see you in another video. If you think of subscribing the channel, that will be great. And thank you very much. See you. Bye.